Oh, hello, coming with a bit late. CodingKata, we're gonna do 5Q again. Hopefully something that won't be too hard. Primitive Pythagorean triples. Line new Pythagorean word spiral. Insane. And warriors and lamp. Fuck. Let's see the primitive Pythagorean triples and word spiral. So Pythagoras discovered the relation a2 plus b2 is c2 for rectangle triangles a, b, and c. Angle of 90 in the following animated page. You can see a rectangle triangle with the side values a, b, c, 3, 4, 5. The pink square. I just want to see like found max. Max perimeter, largest triple. So let's see. We have to know we have to number triples below EQ 50, 100, 150, max perimeter, largest triplet. Well, let's see if this one is shorter. Oh, it's a fucking spiral again. Oh my badoosh. Hello, your task today is to create an algorithm. You do not have a description of what it should do. All you have are the inputs and outputs. All inputs are strings and all outputs are required to be. Example, input A, B, C, D with all the way to Z, and you got it from like from the oh, what? Ah, okay. I kinda get it. I kinda get it. There's as many. Well, I don't get it. Shit. D. D. Wow, that's what a mindfuck, man. Buying the farm. To buy the farm means to die. Castle of cubes. Windmill cycle. Ziggurat, ride of fortune. What ziggurat? It's like a Aztec mosque or something like that. Castle of cubes. You have been hired by a castle building company. Their procedure is very simple. In their castles, all the rooms are the same cube. They build thousands of the same square stone panels and assemble them. Neighboring rooms share one same panel between them. Business is growing fast, so they need your help. The customer has only one variable, n, the number of rooms. For energy saving reasons, the surface of the castle must be minimum. For any given n, multiple floors are possible. Say what? Example. 0 0 1 6 panels. Oh, because it's like 1 2 3 4 5 6, like because there are cubes, I guess. So it's like 2 rooms, and you need 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10 11. And they're like all holding together. So basically you say n times 6 minus the like amount of panels that are the same, you know. um, so uh, where's the, oh, this is, oh, camel. How old is camel language? Uh-huh. Leroy. Leroy Jenkins. Yes. Like this guy ain't even that old. Ziggurat. Windmills, like, oh, this shit has a GIF. Wow, this looks so complicated. Or maybe not. Huh. Alright, so is there a way for us to find like the right amount of chambers? Neighboring rooms share same one panel between them. For energy saving reasons, the surface of the castle must be minimum for any given n. Multiple floors are possible. So there's just like one tower, or what? The surface of the fucking, so it's just a tower. So it's like, oh, 36 plus 30 plus 1 is plus 5. So this is, wow, so if I understand correctly, like this is very easy, because you just have to return, fuck. Alright, so you just return n times 6. I don't know if Python like understands that, but then minus n minus n minus n minus 1, if I'm correct. Test passed. Failed for n is 1. 181 should equal 141. Uh-huh. Zero. Uh-huh. Oh, so yeah, the algorithm. Alright, I understand. It's like the algorithm is algorithmic, you know. You got some, like, it seems obvious at first, but then it's not obvious in the second, you know. Right now we're in the second. So we could solve like the first one. Say if n equals 0, return 0. Like sometimes they're just not getting away with that. but right here we got the like 40 difference of 40, you know. And they say you've been hired. In their castles are all the rooms. All the rooms are the same cube. They build thousands of the same square stone panels and assemble them ground wall ceiling. Neighboring rooms share one same panel between them. Aha, so they share one same panel, so it instead of a tower, it's a cross. You know, or maybe even yeah, it's only one cross, I guess. So in that way, if I would say if n is 1 2 oh 1 2 3 4 5, so if n is less than 6, return that. Test. Now here, yeah, alright, here won't even return. Now it say if n is larger than 5, we want to return. What do we want to return? It's like shit. It's like that, n times 6 minus n minus 1, but also there's one minus more, and you could say minus n and minus 1, no, and minus 5. Well, let's test that out. No. Oh. None. Alright. So it's not n minus 5, 1, 2, 3, 4, 5. And if I understand the rules correctly, like it says, neighboring rooms share one same panel between them. Business is growing fast, so they need your help. The customer has only one variable, n number of rooms. The surface of the castle must be minimum for any given n. So, I mean, the surface of the castle at minimum is always only one cube, you know? This seems simple at first, but I guess it's not. Yeah, should the area not be 5? Yeah. Yeah, like the creator of the this deserve a picture. Like if we have, I mean, this one takes care of the walls that are between them, I think. Oh, damn it. Like, it doesn't. Like, it really feels I should approach these katas differently since they are kinda harder than all the previous ones. But today I just wanna make one. It seems like every day I just wanna make one, but today I still wanna make, like, I won't, like, force myself, man. Um, huh. Playing ping-pong service problem. This looks like a good one, although not that hard. I know this guy. Playing ping pong can be really fun. Unfortunately, after a long and exciting play, you can forget whose service turn it is. Let's do something about L. Write a function that takes the current score as a string separated by that sign as an only parameter and returns first or second, depending on whose service turn it is. We're playing old school, so the rule is that players take turns after every 5 services. That is until score is 2020. From that moment, each player serves 2 times in his turn. Oh. Players take turn after every 5 services. There is no need to check if the past parameter is valid. The score will always be provided in correct syntax, and you don't need to check if one player has already won. That won't be the case. Alright, so it's interesting, more than I thought. And what we have to do is basically count together the number of servings. So we say number of servings equals to we turn into int we turn into int we say int and say score dot split at this sign and then take the 0th one plus the same thing but the first one. Why don't you copy? You should oh fuck. Copy. Paste. Alright, so let's see if it's good. Just test it out. Number of servings 5. Yeah, it works. Ha. Nice. Alright, and then we just do based on the number of servings. Like if number of servings divided by 5. So and this is like floored division, or like, let's ignore that and just see what that does. Number of servings, and then we print that. Shit. We print that, and we print the number of servings, and then we do that and 5 and see what happens. 1.0, 2.0, 4.4, and if we floor it, it's like 1, 2, 4, 5 per second. Alright, so we just say if that is divisible if that modulo 2 equals so if all of that divided by 2 is 1, return first, else return second. Now this should probably be all green. Oh shit, I mixed them up. Yeah. All of them pass, but all of these should not pass, because the algorithm still not proper. For example, let's check the no 0, 0 is wrong. It's all over 20. Now when we're over 20, and we have to do it over here, if number of servings is more than 20, what do we do then? Until the score is 20, so actually when it's over 40. Or is more than or equal. What then? We just say each player serves 2 times in his turn. So it's more than 40, because I'm like wondering whose turn it is when there's 40. Alright, check our algorithm, which apparently is correct. 40 divided by 5 is 4, divided by 2 is not 1, so is the first player's turn. And when we are the alright, now I'm getting, so this is now basically the same. It's only hard to imagine or do it like just imaginary. each player serves 2 times his turn. So you got first player serves 5 times, second player serves 5 times, first player serves 5 times, second player turn like serves 5 times, and the 41st, no, the 50th, oh, and that happens like one time all over again, and then the 41st time the first player serves, and the 41st and 42nd is the first, and 43rd and 45th is the, no, 43rd and 44th is the second player, and so now we must just see. So is it always like that? Let's comment it out over here. So there's always first, and it's 41, 42. The second player is 43. The second is also at 44, and and the first one is 45, 46. Second is 47. Second is 48th, and then first is again 49th, and then 50th, and then the second player is 51. Oh, so it changes every time, it changes, or all the numbers, if the first number is like an odd number and the second is not. All right. All right. So the thing is, if, and then like if if iffy. I know it had to be a better way. I solved kata every day. I knew it had to be a better way. Because the pattern is right here, we just need to find the right rule to it. And if we like divide and floor, if we divide and floor the number or I have a no, I don't have a crazy idea, or maybe I do, or maybe I don't. Yeah, I don't. Well, hold up. I could say, and we say so we say, here we say servings equals to 41 and player is first, then say while number or while servings is less is all right. I'm just gonna shut up for a few seconds while still programming. Cool. Yes. Servings is not equal. Servings is less. The number of servings times say nice. So if player is first, then we want to assign the player variable to the second and vice versa. And that should still, oh, invalid syntax, yeah, I hear you. So this should all be green, and this shouldn't be green, but it should be green more than before. And all right. So you want, like, are these tests randomized? 82, yeah, they are. So if servings, while servings, well, at least while loop doesn't go to infinity, am I right? And we say while servings is not equal to the number of servings, we say +1, and then we change them only when two of them pass. So we say loop counter starts at 0, and then we say always increment loop counter by 1. So how do we check that? Plus equals, alright. Plus equals by 1, so it's on 41st. Oh, it starts with 1. And when there's 2, 1, and it shall be then 1 and then 2. Then we shall say also if loop counter equals 2, run this one, and also set the loop counter to 0 again. Wow. Is it right the other way around? Nah. Yeah, just other kind of test fail or pass. So when it's over 40, so say we got 5. This is the first. 10, second. 15. Oh, 0th, the first one's turn is. When there's 5, the second player's turn is. When there's 10, it's again the first dude's turn. When there's 15 is the second, when it's 20 is the first. So when there's 40, or it's more than 40, when the number of servings is more or equal 40, we say servings is 40 and player on the round is first, and then we count, then we play. Servings is not equal to the number of servings, we say. So for example, if the number of servings is 22, or here, yeah, it's or 42, it's actually 42. So I just first test that. I mean, it's wrong, I guess. Yeah, first should equal second, so we just say here is the first loop counter. So while servings number of servings, so we say servings +1, loop counter 1, servings 41, loop counter 1, yeah. and it just goes again, and it says servings, number of servings is +1, so here's already 2. I mean, there's 42. Huh. Oh, okay, the loop is flawed. Fuck, I think I'm like too slow for this kind of thinking. Shit. Alright, I ain't, I know. I just have to figure it out. Cause it's like when we were at 40, you're at 41, and then there is the loop. We say, oh, it's like forgetting to return it. So we're at shit. All that for nothing. So we say, oh, I lost it now. So we say, well, servings is not equals to the number of servings. Then we say plus 141, 1, and then servings plus 142, and then there's 2, and if loop counter is 2, then if player is second, player is first or second, well, that doesn't really matter. We just have to return the player variable, and that should be it. Yeah, and that is it. Yeah, all of them pass. Of course, we just like maybe that thing before could have also already passed too. We just don't know. It ain't pretty, you know, but and it probably isn't very understandable, but it's understandable for us, and that's kind of enough for today, you know. Wow, what a short one. Badoosh condition. So it's divisible by 10 and it's less than 5. Wow. If turns 40, if turn is less than 40, else turn divisible by 4, modulo 4 is less than 2. What the fuck? Wow. It'd just be good if we could like understand this solution. Well, it's marked as clever, not best practice. This is marked as best practice. So I kinda get that, you know. We also did that turn, you know, some of them. Condition. If so, do that. If that, else do that. Alright. And that's like true or false, and always if it's true then it's first, and if it's false it's second. Shit. Alright. And if turn is less than 40, then how do we determine whose turn it is? We just modulo 10. Like, what do we get when we divide the turn by 10? And if it's less than 5, oh, okay, this is a good one. Alright. And then if we divide the term by 4, then if the modulo is less than 2, it's again. This is kind of like I kinda understand it shallowly on an intuitive level. Probably not. Let's see the discourse to see all those hidden comments that we got before. Oh, it's just a bunch of code. Well, whatever. Thank you for sticking with me today with this ping pong service problem. Have a wonderful day.